All right, pre-algebra. You should be open to page 133, I believe. That was your homework from last night. So it should look like this. I'm going to go through each of the problems individually with you just to make sure you understand everything from yesterday's lesson. If you did not do your homework, you should be writing this down as you go so you have these examples and what you need as you move forward. So in number 1, it says the table below represents the number of minutes Francisco spends at the gym each day for a week. The question is, does the data shown represent a function? So remember that a function is a situation that makes sense in real life. In order to make it make sense, all inputs, or x values, must have only one output, or y value. So here, since each one of our x values only shows up once, none of them repeat and have a second y value, yes, it is a function. All right, moving on to number 3. Number 3 up here at the top, Olivia examined the table of values shown below and stated that the possible rule to describe this function could be y equals negative 2x plus 9. So when Olivia says that the rule could be y equals negative 2x plus 9, she means that the table of values comes from that equation. So if we are checking to see if her rule is correct, we have to check to make sure that each input, x, gives you that output, y, in the equation. So we're going to take her equation, and instead of writing x, we're going to substitute it for one of our x values. So I will just use this first x value, or input, in the table. So when I substitute negative 4 in for x, and I multiply that all out, I get that y equals 8 plus 9, which I know means that y equals 17. Since that is the y value in this column, when my input is negative 4, my output is 17. That's true in this equation. So far, our rule works. We would have to check every single one of these values to know if Olivia really did find a rule that works for this table. For time's sake, I'm just going to check one more of them. So I can pick any one I want. I'm going to pick this 12. So if y is equal to negative 2 times x, which is 12, plus 9, I would multiply that. I get y equals negative 24 plus 9, which I know is negative 15. So far everything checks out. Again, you would need to check every single value if you were doing this thoroughly. I'm just checking those two values for right now. In fact, they all do work, so we would say yes, Olivia is correct, because every input in this table gives us that output when substituted into her equation. All right, your next problem was number 7. That's on a separate page. Let me get that here. All right, number 7. This is a problem we're actually going to come back to in almost every lesson throughout this module. Selling bags of candy. So it says, examine the data in the table. The inputs represent the number of bags of candy purchased, and the outputs represent the cost. Determine the cost of one bag of candy, assuming the price per bag is the same no matter how much candy is purchased. When they tell us that the price per bag is the same, no matter how much candy is purchased, what they mean is that we have a constant rate. So we can determine how much one bag of candy costs by dividing our cost for 4 bags by the number 4. When we do that, we get $1.25. So that means that one bag costs $1.25. Now, you guys were really good at this in Module 4, so I'm sure that you're able to fill this table out pretty accurately from here. So if we know that one bag of candy costs $1.25, and we know 2 bags is going to be $1.25 times 2, which is $2.50. And we just keep going up from there. So this is $3.75. I hope I'm doing this math right mentally here real quick. $6.25 plus $1.25 is $7.50, and then $8.75. So that was just filling out the table. Part A, though, says write the rule that describes the function. So we need to think about what Olivia did in number 3. And when it says to write the rule, that means that we have to write an equation that would work for every value in this table. We know that we have a constant rate. So that means that our equation is going to be linear, which means that we're going to use our formula y equals mx plus b. We know that constant rate is the same as slope. So if the cost of a bag of candy is $1.25 for one bag, that's our slope. So our equation is y equals 125x. Sometimes I need to think about my y-intercept. Sometimes it's 0, and in this case it is 0 because if I were to buy 0 bags of candy, how much would that cost? $0. So that would be plus 0. I don't need to write that though. All right, the next part is, can we determine the output for an input of x equals -4? Remember, our output is always our y value. So it's just asking us to substitute -4 as our input for our x and figure out our y. So we're going to rewrite this equation. I'm going to do the work over here. My equation is y equals 125x. So since it wants me to input -4, I substitute my x for -4. That means that y equals -5. So I completed part B, but in part C it asks, does that make sense in this situation? So does it make sense to buy -4 bags of candy and pay -$5? No, definitely not. So there are restrictions on this problem. We know we can't buy negative bags of candy because it doesn't make sense in the real world. We also know that all of our bags of candy, all of our inputs, our x values, have to be whole numbers because no store is going to let you come in and buy half a bag of Halloween candy. So not only do we have this nice rule here, we also have restrictions or things that can't happen. We can't buy negatives. We can't buy decimals or fractions. I want you guys to go back to number 6 now. This one was not assigned to you for homework, but I want to use this table to help you practice identifying if tables are linear or nonlinear. So we know that if it's linear, there's the same slope between every set of points. We could rewrite each of these as an ordered pair and use our formula y2 minus y1 over x2 minus x1. That would be unnecessary work though, and I think that you guys will find that if we do it the way I'm about to do it, it organizes it a little bit more, it gives you a better visual. So what we're going to do is actually just look and see how much are we increasing or decreasing by for every input. So I like to just draw these little arrows and say, well, from -1 to 0, I'm going up 1. From 0 to 1, I'm going up 1. So you can see I'm going up 1 every single time, which is nice. Nice and easy, small numbers. Now we're going to do the same thing for our outputs. I went up 5. From 8 to 13, I also go up 5. I also go up 5. So I'm going to do that every single time. This one, I happen to be going up by the same values every time. That is not always the case. Even if it's linear, that is not always the case. We know that our slope is delta y over delta x. That was what we learned when we were first talking about slope. Delta means the change in my y value. So this is the change, or how much it changed from one point to the next of my y value. This is the change of my x value. So in order to find my slope, I need to take the change in my y over the change in my x for every pair of points. You can see in this one, it's always going to be 5 over 1. Sometimes it might be 10 over 2 or 15 over 3. It might be something else that still simplifies to 5 over 1. So we always have to divide it and simplify it first before determining if it's linear or not. Since every single one of them is the same value, they all simplify to 5 over 1, we would say that yes, this is linear. All right, we're going to do the same thing for number 4, part A. I want you to pause the video while you try that one on your own. It's this one right here. And then once you think you've got it, you can push play and check your answer. All right, if you're listening to this, you've already done 4A and you are just ready to check your answer. So we're going to do the same thing we did in the other one. We are increasing each time. Here I happen to increase by 1 every single time. Again, that will not happen every time. That's just a coincidence that it's happening in these two problems. Here I go up by 2. Here I go up by 22. I'm actually going to stop right there because now I can tell that if I do my delta y over delta x here, I have 2 over 1. Here, my delta y over delta x is 22 over 1. Is 2 over 1 equal to 22 over 1? Definitely not. So it must be non-linear. All right, next you're going to find a linear function sort on Google Classroom. You're going to complete and submit that before you move on to the second video.